Well, we are going to simulate this time a coaxial cable. It's a very simple simulation inside FEKO. First step, we need to define the dimensions of our coaxial cable. We can get this any analytical online application where the analytical equation for the impedance of a coaxial cable is shown. We found this coaxial cable impedance calculator from Pasternak, and here we can see we assign 3.3 centimeters to the largest cylinder radius and 1 to the small one. To a dielectric constant of 2, we get exactly 50 ohms. So how can we get some simulation inside FEKO for this structure? We move to our CAD FEKO. We create a model. First, we define a couple of variables. Minimum frequency 1 gigahertz. Maximum frequency 2 gigahertz. Our internal radius from this analytical result is 1. Here it says diameter, but from the equation you can see that it doesn't matter if you consider radius or the diameter, the result is the same. So just for the sake of simplicity, we are taking the diameter here and just plugging in 1 here, internal radius, and external radius at here, and external radius we are going to say that it is 3.3. Next, the epsilon R2, this is our material. This corresponds to something like Teflon or something light. Next, the length of our cable. Let's set it to 10. And I guess everything is set. We can close. We can say that these dimensions refer to centimeters instead of meters. And now we can define under media, right click, dielectric medium, just type in epsilon R, create. We have already our dielectric here. First, we design the small cylinder, construct cylinder, origin here. This is the R int, length. This is our first cylinder. As you can see, create. This cylinder is the small one, so it's supposed to be PEC. We design the big one. This is the Rx and length. Create. This instead we call it dielectric. Again, right click here, properties, medium, dielectric. Okay. Now FEKO needs to know that those structures, they are in contact with each other. So we just select both and union. Here there is a warning. We just need to confirm that this small cylinder is actually a PEC material. We're set. This is not quite a coaxial structure because we need to say that this face here, this external face, where is it? Face 6 is properties set as PEC2. This is the shell of our coaxial condenser. So we don't need to create 3 cylinders, just 2 cylinders is enough for our definition. All right, this is our structure. We have the union, everything is set. Next, we need to attach the waveguide port. The port is here. This time we are going to use the waveguide port. The waveguide port should be assigned to this dielectric face here. This dielectric face here, you can see, is here, phase 5, selected. We can move to waveguide port, create. We do the same for the other side. 3, 4, there we go. Waveguide port again, create. We have the 2 ports set on our segment of coaxial transmission line. Now we select waveguide source and we say that the port number 1 is excited by a generator. Create, done. Frequency here or here, we say that we are covering from F min to F max, let's say 11 points. What else? Requests. Let's ask for the near fields, 2 cut planes. First cut plane 0 minus 2 times Rx. Here is 0 and here is 0, 2 times Rx, and here is 2 times length. Just make it different, Ctrl C, Ctrl V. We make it symmetric. There we go. This is the kind of structure that we are going to use. Maybe this one here, instead of twice the length, we use just small. All right. And here, because it's a plane, we are going to sample only V and N. 21, 21. This is random numbers just to get a nice sampling. Add, and now another plane, cut plane. This time is not longitudinal but transversal to the transmission line. This time is minus Rx. Ctrl C, Ctrl V. Minus length over 2. Here is Ctrl V. Rx positive, Ctrl C, Ctrl V, and here is length, Ctrl C, Ctrl V over 2, but this time is positive. Something is wrong here, minus. There we go. It was wrong. This is not negative. And here we have, this is not changing, so this is 21, this is 21. There we go. You see, it shows, FEKO shows the points where the field is supposed to be sampled. Create, done. Now we can move to our frequency set. Waveguide source, 2 ports, everything seems alright. We can mesh, just the standard mesh, just make it fast. You see the mesh automatically created. We move to solver run, CEM validate. Maybe we made some mistake. Everything seems alright. We move then to the FEKO solver. We save it. Any name. Simulation is finished. We can move to post FEKO and see what kind of results this simulation gives us. Well, here we have the Cartesian graph. You can see that we have a pretty much matched structure, which makes sense because we have 2 ports on each side on each end of the transmission line. We can see the same result on the